I want to work the problems on page 136, 3 through 57 odd, and number 63, so that you can check your work. So here we go, beginning with problem number 3. In problem number 3, I'm finding the derivative of a constant, and the derivative of a constant we know is 0. Problem number 5, we have a power function, x to the 6th, and the derivative of that power function using the power rule. Remember, we're going to multiply the coefficient by the power and decrease the power by 1. So we get 6x to the 5th power. In problem number 7, we're going to do a rewrite first. So we're going to change that 5th root of x into x to the 1/5 power. So we get our function into power function format. So when I find the derivative, I'm going to apply the power rule. So I'll multiply the power of 1/5 by the coefficient, which is 1, x to the. Now, when I decrease the power by 1, my current power is 1/5. I'm going to decrease the power by 1, so I'm going to need to represent that as 5 over 5 to get a common denominator. And so when I subtract, I'll get negative 4/5. So the new power is negative 4/5. And if you need to write those fractions out, write them out. Get it right. Problem number 9, quite simple. The derivative of x is 1, and the derivative of that constant 1 right here is 0. Number 11, I have a quadratic function. This one's pretty easy to find the derivative of. So I'm going to use the power rule on the first term. The power of 2 multiplied by the coefficient of negative 2 gives me negative 4t. Decrease the power by 1, and I get to the first power. Second term, the derivative of 3t is just the coefficient 3, because I'd get t to the 0, and t to the 0 is 1, and then the derivative of that 6, that constant, is 0. In number 13, I have a cubic function. Applying the power rule, I will get 3t squared minus term 2, the derivative of 2t is 2, and the derivative of that constant 4 is 0. Problem number 17. So this function is comprised of a power function and an exponential function, a special one, that e to the x. So first term, I can use power rule. The derivative of 6x is 6. And the derivative of the second term, now remember the coefficient, that 5 does not inhibit or do anything. I'm really just thinking about taking the coefficient of e to the x. And the best thing we like about e to the x is that it is its own derivative, as we saw in class. So the derivative of e to the x is e to the x, and the coefficient stays there. So make sure that you understand, in that case, there was a term that required the power rule. That was the first term. And then the second term required our memorized derivative of e to the x. In number 19, let's take a look over here. Don't be bothered by that coefficient of pi over 2. Pi over 2 is a number. It's a perfectly fine number. It's a coefficient. You would treat it like a 5 or a 7. What you want to focus on is knowing the derivative of sine, and you've got to get that memorized. So y prime is equal to, coefficient stays there, the derivative of sine is cosine of the angle. Term number 2, we're looking at the derivative of cosine. Now notice there's a minus in front of that. The derivative of cosine is negative sine of theta. So that negative multiplied by the negative that's already there makes that a plus sine theta. Again, you've got to memorize those two trig derivatives. They'll go pretty quickly. You just got to practice with them. Problem number 21 is comprised of a power function and a cosine function. So the derivative of the first term, x squared, becomes 2x. The derivative of cosine, as we just talked about, is negative sine multiplied by the negative that's there. Coefficient stays, so that's plus 1/2 sine of x. Number 23 we have an exponential, e to the x, our special function, and we have sine x. So the derivative of e to the x, coefficient stays, is 1/2 e to the x. Love that part. Second term, the derivative of sine is cosine. Coefficient stays. Derivative of sine is cosine. So that's 1 through 23 odd. All right, let's move on. It looks like I'm missing some problems here, so let me go and find those real quick. So I'm going to pause this video. So I went back and took a look at the problems that are missing, and they are intentionally missing, and they are not in your packet. So we're good to go, even though the assignment says 3 to 57 odd. We're not doing the ones that are not on this page because you do not have those. So I'm going to jump down to 31. Let's start by reading the directions. In these exercises, find the slope of the graph. So we know that that means derivative. At the indicated point, and use the derivative feature of a graphing utility to confirm your results. So I'll take the opportunity in this section to show you how to use your calculator to find the derivative. So that's a great benefit of watching this video. So I'm going to begin with problem number 31. And number 31 needs a rewrite first. So I'm going to change that into f of x equal to 3. I'm going to bring that x out of the denominator, so I got to bring the power up and make it negative. So that's going to become f prime of x. Now I can apply the power rule. Negative 2 times 3 is negative 6. Now be very careful here. We're going to decrease the power by 1. Your temptation is going to be to want to change that into a 1, but actually when you decrease that power, you get to the negative third power. Now I'm okay with leaving the answer in that format, but you can, and the book probably will, change that into negative 6 over x to the third. But I'm perfectly okay with this format of the answer. Now they do ask me to find the slope at the point 1, 3, so I only need the x value to do that. So I would have f prime of 1 is negative 6 times 1, times 1. Let's wait for my eraser to pop up. There we go. So times 1 to the negative third power. And you can see if we're calculating this actual derivative, it might be easier to put it in this format over here. But 1 raised to any power is 1, and 1 times negative 6 is negative 6. So f prime of 1 is equal to negative 6. And now I'm going to show you on the calculator how to handle that. So as you can see, I have brought my calculator up on the screen, and you probably have a TI graphing calculator, but it may not be the same model as mine. So some of the commands may be a little bit different on different calculators, and I'll try to walk you through that. But the calculator can actually find derivatives for us. Let me get this out of the way. You browsers, I don't want the browsers to view. Right, so let me get my calculator back up here. So to find the derivative, I'm going to show you first on the home screen. So you're welcome to write these steps down. So to find the derivative, you're going to go to the math button, which is right here. So you're going to do math. And if you look right over here, I want to find derive. I want to find the derivative. D-E-R-I-V stands for derivative. So I'm going to select number 8. And now, at least on this model of calculator, it's telling me to put in some various values. So the first thing I'm going to tell the calculator is I'm taking the derivative with respect to x. That just wants to know what variable we're taking the derivative of. Then they want to know, what are you taking the derivative of? So in our problem, we can type it as it was written. We could type 3 over x squared, or we can type 3x to the negative 2. That doesn't really matter. So I'll do 3x, and since I already rewrote that, I'll raise that. Where's my 3x to the, there it is, to the negative 2 power. And then over here, it's asking me, what value of x do you want me to find the derivative at? And we wanted to find the derivative at 1, so we press enter. Now, notice the calculator, sometimes it has these little pixelation problems. Negative 6.00012, they're really trying to tell us 6. However, if you have an older model calculator, your calculator, when you press math number 8, it will type this onto your screen. It'll say N derive, and it'll put a parenthesis. So if that's the model calculator you have, here's what you always do. So you're going to begin by putting in the function. So in this case, we would have 3x to the negative 2 power with a comma, and the comma is right above the 7. And then you're going to tell it what variable we're in, which the variable that we're using is x, separated by another comma. And then you're going to put in the value at which we want to find the derivative, which is the same kind of information we put in on the newer style calculator. And then you're going to press enter, and then it will give you the answer. So again, the syntax is type in the function and then put a comma. X always goes there because that's going to be the variable, and then a comma, and then the value that you want to find the derivative at. So that's how you do that on the older model calculators. Right, now another way to do that is to go into y equal to. So let's say we didn't want to do it on the home screen. I'm going to do the same thing. I'm going to put the function in, and this time I'm going to put it in as 3 divided by x squared. That's the way the problem originally gave it to me. And so when I have that into my calculator, I'm just going to do a Zoom 6 window to get a standard graph. So there's my Zoom 6 window. Don't necessarily have to get the graph. And so to find the derivative to get the same answer, I'm going to tell the calculator second calc or second trace, however you think of that button. And notice in number 6 we have dy dx, which stands for, that's a format of the derivative. So I'm going to select number 6, and down here it's waiting for me to tell the value of x that I want to find the derivative at, which in this case is an x value of 1. And then I'm going to press enter, and it's going to give me and tell me that the slope of the line tangent to the curve at that point is -6. So if you want to work on that again and learn those calculator steps, you can just play the video back. I'm not going to do that for each one of them, but I thought it would be a great opportunity to teach you how to use your calculator to do that. Okay, so let's see if I can get rid of this here. There we go. Let's go to number 33. Get my pen, go to 33. I'm going to do that one over here on the right-hand side. So number 33, I'm going to do a rewrite. That's f of t is equal to, notice a lot of time, one of the biggest things, oops, I almost did 32, 33. No, I don't need a rewrite on number 33. I was looking at number 32. So I'll just go ahead and say f prime. So 33, the derivative of -1/2, the first term is 0 because that's a constant. The derivative of the second term, I can use the power rule. So I'm going to multiply the power 3 times the coefficient, which is 7/5, and 3 times 7/5 gives me 21/5 as the coefficient. Keep the variable, and now I'm going to decrease the power by 1, so that'll bring me to the second power. They want me to find the derivative at 0, so I'm going to substitute 0 in here. And of course, I will get a derivative of 0. And if you want to use your calculator to practice that, now that would be a good opportunity. All right, let's go on to number 35. I'll come back over here on the left side. So number 35, I do not need a rewrite. The first term is 4 sine theta, and the derivative, so f prime of theta. The derivative of sine theta is cosine theta. Remember, the coefficient comes along for cosine theta. And don't be alarmed by this theta. It's treated just like an x. So the derivative of theta, it's just my variable in this case, is going to be 1. So 4 cosine theta minus 1. And they want me to evaluate that at 0. So f prime of theta, 0 is equal to 4 times the cosine of 0 minus 1. And remember, from your unit circle, 0 is here, and cosine is the x value. So the cosine of 0 is 1, so that's 4 times 1 minus 1, which is equal to 3. Number 37, our favorite function ever, except for it's got e to the t instead of e to the x. So the derivative of f is going to be, keep that coefficient of 3/4. The derivative of e to the t is e to the t. And now we're going to evaluate that at 0. So f prime of 0 is 3/4 e to the 0. E to the 0 is 1. And 1 times 3/4 is 3/4. 37. All right, I'm going to go to the other side to do number 39, or yeah. So I'll do number 39 over here on the right-hand side. So in number 39 to 52, we're just finding the derivative. So g prime of t in number 39, term 1, the derivative of t squared is simply 2t. The derivative of, let me come back over here. I should have done a little rewrite, but I'll do it over here beside it. So this is 4t to the negative 3. So I'm going to multiply the power by the coefficient. Now notice that there's a minus sign here. So negative 3 times 4 is negative 12 times that negative makes a positive 12. So I have plus 12t. And when we decrease negative 3, we go to negative 4. Again, it does not matter. I do not care if you bring that back down. The textbook probably will. Number 41, very, 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 very famous problem. Since we have a monomial denominator, I'm going to do a rewrite. Students, do this. I'm going to break up that one fraction into 3 fractions with the same denominator. I'm just using 4th grade math. What I know about fractions, plus 4. And instead of writing that as over, well, I'll go ahead and do that. Okay, that's phase 1. Notice there's no prime. I am not finding derivative. I just did arithmetic. Now I'm going to do some algebra. Whoops, not prime yet. I'm not ready to do the prime. I'm just going to continue with my rewrite. I'm getting it ready for calculus by using some arithmetic and some algebra. All right, there's my eraser. So f of x, original function. When I simplify the first term, I'll get x to the first power. When I simplify the second term, the x squares divide out. And when I simplify the third term, I'm going to bring that x squared to the numerator to get it in power function format. Now I'm going to take the derivative. So the derivative of x is 1. The derivative of negative 3, a constant, is 0. And the derivative of 4x to the negative 2. Multiply power by coefficient and decrease the power. Decrease the power. I'm waiting for my computer to get this thing out of the way. I don't know if you guys can see that or not. Decrease the power by 1 gives me to the negative 3rd power. Number 41. Number 43, I'll come back over here on the right-hand side. It needs a rewrite because it's not in power function format. So to begin number 43, I'm going to distribute and distribute, and so that will give me x cubed plus x. Now I'll take the derivative, and the derivative of x cubed is 3x squared, and the derivative of x is 1. In number 45, I'm going to do a rewrite, so I'll have in 45 f of x equal to x to the 1/2 power, here come our fractions, yay, minus 6x to the 1/3 power. So when I find the derivative, be careful with these fractions. You want to multiply the 1/2 times the 1, so you get 1/2 x, decrease the power by 1, so 1/2 minus 2/2 is negative 1/2. Minus, I'm going to multiply 1/3 times 6, which is 2x, and got to do that fraction work again. 1/3 minus 3/3 is equal to negative 2/3. All right, that's number 45. All right, I'm going to clear the screen and give myself some more room here. All right, we've got number 47. In number 47, I'll start back up over here, except let me change the color. In number 47, we've got more fraction work, so I'll have h prime of s is equal to 4/5 s, and remember, do that fraction work, write it out if you need to. 4/5 minus 1, which would be 5/5, is negative 1/5. Second term is minus 2/3 s, and then I've got to take the original power of 2/3 minus 1, which is 3/3. That gives me to the negative 1/3 power. Number 47. 49. I'm going to do a rewrite first, and I'll make that f of x equal to 6x to the 1/2 power. Cosine is fine. 5 cosine of x. Derivative of the first term, 1/2 of 6 is 3. Decrease that power by 1, so 1/2 minus 1, which is 2/2, is negative 1/2. The derivative of cosine is negative sine, so I get negative 5 sine x, 49. 51, derivative is negative 2x for the first term. Oh, minus, I didn't decrease the power. Minus negative 2x to the decrease the power by 1 gives me negative 3. The derivative of e to the x is e to the x, and I keep the coefficient of 2. All right, I'm going to come back over on the other side for number 53. We've got some new, let's go ahead and clear the board here. Okay, there we go. In number 53, our directions are find an equation of tangent line to the graph at the point and use a graphing utility to graph the function and its tangent line at the point and use your derivative feature to confirm your result. I may or may not pull the calculator out for that. We'll see. So in number 53, the first thing I'm to do is to find the derivative, because that's going to be my slope generator, 53. So y prime, slope generator, derivative is 4x cubed minus 1. And the given point is negative 1, 2. So I'm going to find the slope at the value of x. So derivative at negative 1 is 4 times negative 1 cubed minus 1. So that gives me negative 4 minus 1, which is negative 5. So that is my slope of my tangent line. Now we talked about when we write equations of lines, we're going to use point slopes form. So I'm going to write down my model. Y minus y1 is equal to m times x minus x1. So back up here, this is my x number 1, my y number 1, and my slope. So all I have to do is fill in everything that I already have. So y minus 2 is equal to slope, negative 5, times x minus negative 1, which is x plus 1. And the only other thing you have to do is add the 2 to the other side. So negative 5 times x plus 1 plus 2 by adding the 2 to the right-hand side. And if you want to, you could graph the x to the 4th minus x and then type in the equation of your tangent line and go, ooh, that really is tangent at the point negative 1, 2. Let's see, what was our assignment again? We're not going to do 55, clearly, because it's not here. So we're going to 57 odd and number 63. 63 is a fun one, but let's get to 57 first. So in number 57, our directions are determine any points, if any, where the function has horizontal tangent lines. So reading is really important. So we have to think about horizontal tangent lines. We know that a horizontal line, this is our brain work, horizontal line has a slope of 0. So they're really telling us to figure out where is the derivative of this function equal to 0. because if the derivative is equal to 0, then there will be horizontal tangent lines. So that's my instruction right there. Figure out where the derivative equals to 0. So first, I'm going to have to find the derivative. So up here in number 57, the derivative of this function is 4x cubed, power rule, minus 16x to the first power rule, and the derivative of that constant 2 is 0. So phase 1, I found the derivative of the function, and now I'm to set that equal to 0 to figure out where the graph has horizontal tangents. So I have 0 equal to 4x cubed minus 16x squared. To solve that equation, I'm going to factor out the common factor of 4x. That leaves me with x squared minus 4, which of course is factorable. So I get 4x times x plus 2 times x minus 2. I'm going to set each factor equal to 0 and solve. So I get x equal to 0, x equal to negative 2, x equal to positive 2. So there are 3 places on that graph where there are horizontal tangents. And I think that actually might be worth, oh, I think I put my calculator to sleep. So I would encourage you to go in and type this into your y, oops, get a color. Type this into y number 1. And take a look, and then look at x equal to 0 and negative 2 and 0, negative 2 and positive 2, and you'll see that you're going to have horizontal tangents there. All right, number 63 is probably the problem that you have all been waiting for in this set. So let me just clear the screen, and I can tell you right now that reading is the most important thing. So let's carefully read through that together. In 63, I'm finding k, so there is a mysterious value. You don't have to write this down, but this is really what's happening. There is a mysterious value that I am to find, and his name is k, such that the line given, so here's the line right here, is tangent to the graph of the function. Okay, so let's think, what in the world does that mean? So let's try to get a little bit of a visualization of what's going on. So I have this function, it's a parabola, x squared minus kx. So I'm just going to draw an random upward parabola over here. So I have this upward parabola, and then I have this line over here, and this line is 4x minus 9, which has a positive slope. So somewhere on this graph, this line, 4x minus 9, is tangent. Again, that's a random selection. I just selected a point. That yellow line is tangent to that curve. Well, what does that mean? Well, if that's a tangent line, that means that the derivative at that value of x is equal to the slope of the tangent line. So let me kind of write that out. So the slope of tangent line equals or is the derivative. Well, that's kind of nice because over here we can see that the slope of the tangent line, the slope is 4, which means that wherever this parabola and line intersect, the derivative is 4. Slope of the tangent line, derivative is 4. Now the other thing that we notice about the line and the parabola is that they intersect at that point. So it would be kind of nice to know where, and an intersection means they equal each other. So one fact that we know is that x squared minus kx is equal to 4x minus 9. In other words, the parabola and the line equal to each other at this point of intersection right there. So that's my algebra implication. That's why I set them equal to each other. Now over here on the other side of the screen, the second implication that we have that I just said is that the derivative of the parabola, so f prime of x, the derivative of the parabola is 2x k is a constant or a coefficient, and the derivative of kx is k. Now think about what we said over here. We know that the derivative is equal to 4 because, come back up here, the slope of the tangent line is derivative. So now we know, so we have two implications. We have a algebraic application and we have a calculus application. The calculus application is that we know that 2x minus k is equal to 4. All right, so over here we have an equation, and over here we have an equation, which means we have a system of equations that we can solve. I think the easiest way to solve this system of equation is to come over here to the right-hand side and get k by itself. So that if we got k by itself, I would subtract 2x on the right-hand side, and then I would divide by -1 both terms, so that would give me positive 2x minus 4. I'm going to take that representation of k. I'm going to bring it all the way over here and substitute it in, because this is the algebra phase. So x squared minus, substituting 2x minus 4 in place of k equal 4x minus 9. Totally algebra at this point. So x squared minus, distribute, parentheses, 2x squared, and that is minus 4, yeah, minus 4x equal 4x minus 9. Distribute, so x squared minus 2x squared gives me negative x squared. Distribute the negative gives me plus 4x equal 4x minus 9. I can subtract 4x from both sides, and that leaves me, bring the screen down, oh, I'm going to have to make some more paper. So that leaves me on the left-hand side with negative, come on, you can do it, come on, you can do it, there we go. So that leaves me with negative x squared on the left equal to negative 9 on the right. Divide both sides by -1, that gives me x squared is equal to positive 9. Take the square root of both sides, and x is equal to plus or minus 3. Now remember, we were looking for the value of k, so evidently there are two values of k here. So I'm going to grab the plus and minus 3. I'm going to grab the plus and minus 3 and bring them back over here. This is a fun problem to end with, right? So k is equal to, if I substitute positive 3, I'll get 6 minus 4, which is negative 2. And if I substitute negative 3, I'll get negative 6 minus 4, which is negative 10. And so those are the values of k that will make the parabola and the line tangent. All right, so I hope this is helpful to you. But before I go, I just noticed that I wrote that k is equal to negative 2, but k is actually equal to positive 2. So hopefully you picked up and noticed that.